Okay, now we have something new to do for today. So we have done through all the presentation. So you can see here. All right. Now today we're going to look at parts and assembly of your CAD modeling. I'm using these 3 books materials for today's lecture. Right. Most of the things you already learned in your technical drawing classes, and you apply what you learned in the technical drawing module in this Capstone Design 2. Okay. Now, before we start, let me get out of the screen. As you can see here, when you generate drawing, you should know that you have a different size of paper. Okay, so we are looking at ISO standard. There will be ISO standard and DIN standard. Okay, so we are more focusing on ISO standard. Of course, if you go working in Europe later on, if you have an opportunity, then they might use DIN, DIN standard. But if you're in Asia or US or maybe Australia, then when you create a drawing or you submit a drawing, most of the time you'll use ISO standard, and you know that you have A1 size, A2, and so on. Okay, so A4 is this size, and so on. Okay, so this basically is the sizes different between A4, and then you increase to up to A1. So this is the more detailed dimension. Why this information is important? Because when you draw your 3D model, you convert your 3D model into 2D drawing later on, you need to set the correct paper size or your drawing size. Okay, so in your software, maybe you are using A1 size, but when you scale down to A4 size, you need to be careful on the scaling from your software and the printout. So just be careful on the conversion when you submit report at the end of semester. Be careful on your technical drawing. You might be using A1 in or maybe A2 in your software. When you submit your report, in A4 size. So just be careful on the conversion of scale from here to here in your software. Right, you need to do some setting from here to A4. So these are the size of the paper that you can check from the slides here. Quite standard, right? Quite standard. So this table will tell you ISO standard. So if you go for let's say A4, so the A4 sizes will be 210 times 297. When we talk about technical drawing, we deal with unit in mm. Okay, throughout your drawing or your submission of a report later on, especially when you come to technical drawing, all your unit will be in mm. So when you draw your 3D model later on, or you convert your 3D model into 2D technical drawing, remember you set the global dimension in mm. Okay, so these are the standard that you should follow. Okay, I think this one you are familiar. Just a recap on that. Second one is a scale that I mentioned just now. Scale means you scale the original size of the model that you draw to the drawing, right? So original scale to the drawing. So just recap, I think you learned this one before. There are 3 categories or 3 types of scaling. If you do 1 by 1, 1 to 1 means original scale, same with the natural scale. Means what you see on paper will exactly the same as the real model. Second one, if you doing an enlarged scale, meaning if the model is very, very small and you put in A4, it will be a big drawing in your A4 paper. So the scale in your drawing later on, this one will be bigger than 1. So you put in the respective scale later on. This number will be bigger than 1. Okay. Be careful. Be careful when you submit your technical drawing later on. Okay. Next lecture we will mention more about your 2D technical drawing. Today we'll focus more on the 3D model. Okay, 3D modeling. But this is just a recall, some information to recall when you do scaling later on. Okay, so original scale 1, 1. So if you submit your technical drawing later on, you put 1, 1. I will put a question mark there. So if 1, 1, I think most of your parts is quite big, bigger than A4 paper, right? So just be careful on the scale that you use in your technical drawing later on. So if it is a reduced size, mean the original size is big than the A4 size, then you use 1 over something, 1 double dot, and then the scale of that one. Okay. So by checking the scale, you know that we can know that whether you understand technical drawing or not. Okay. So this is the first thing. First thing that we check when you submit your report, or after this you go to work later on, when you deal with the technical drawing, your manager or your senior engineer or your chief will, these are the area they will check. So first, when you submit your document, are you using the correct size of paper or not? Then after that, they will go to check your scale, the scale inside your technical drawing. Are you using the correct scale? Because if you make the wrong scale in your drawing, the company might go bankrupt. Might go bankrupt because of very small number that you put inside the drawing. You imagine if the size is this small, so initially you should use this one, right? You should use this scale, but you use the wrong one. You use this one. So when you manufacture the part, your origin initially you plan to have this. Let's say you plan to have this size, right? The correct version is this one, but in your drawing you accidentally put the wrong scale. All right, so you pass the drawing to the manufacturing plant, where the fabrication manager, they will look at your drawing and they will turn your drawing using the scale on the technical drawing. And remember, the technical drawing will be signed by you, so they will assume your parts that you ask them to fabricate is not in this size. Maybe they see the drawing as this big because of the wrong scale that you use in your drawing. And you imagine if the original object, this one, let's say you are fabricating using gold material or titanium material, which is very expensive, and you accidentally use the wrong one, you're going to cost a lot. You imagine this size, right? This size to this size. So it's quite a disaster to the company. And you might lose your job because of these very tiny mistakes. This one and this one. This one easy to spot, but normally you won't use one-to-one in drawing unless you can fit them into the A4 paper, right? But for commercial purposes, most of the time you either use this one or this one. Okay. Any question on the scale? Any one of you're not clear which one to use?
No, sir. I think so far all good.
Yeah. All right. And the next one is that the lines that you use in your drawing. So I think this one you also learned before, just a recall. So you have different line types to use, and each one of them represent different things, different meaning. So when you, in your CAD drawing module, when you do 3D modeling, you convert 3D model into 2D drawing, you come across all these settings. Or if the software can automatically convert, then you should also be aware that the software is using the correct one. So the dot line, dash line, and dash line, and unbroken line. So normally the solid line, like this one, is for the real dimension. And for example, the dot line and dash line usually used for hidden, means dimension at the back, or there's a hole, or there's a perforated parts, that one. Then also there will be a different if you use different line width or different size of your line width. So for example, 0.7 and 0.13, they mean they have a different meaning in the technical drawing. So just be careful not to assume all your drawing you are using the same line. Huh? So later when you pass your 2D dimension drawing to us, or by the end of the report, make sure you check, or when you use your software to draw the 2D drawing later on, check whether you are using the correct line width or not, or correct line type or not. So these are the things that we will check lah. When you go to work, this will be some of the error made by the new draftman, or the new engineer who just joined the company, right? So they haven't know what is the standard used in the industry, and they always mix up with the line type and the type of the line that you should use, right? So yeah, again, all the numbers you see here is in mm. This is just a side note to remind you, in technical drawing, in engineering, we will use mm. Okay. This is another table. If you use a scale 1 to 100, so each one of type of line will mean something. This one, all this explanation is for if you draw a building, then this one means something else lah. Okay. We will come to all these, so you can see the different 1 to 100 and 1 to 50, they have different meaning. Okay, their meaning, even though it is the same line, but they mean something else. Okay, so just be careful when you use different line type there. Okay, so you need to study a little bit on the line type, right? If your previous lecturer didn't mention about this one, so for inside this module, maybe I'll include this explanation on the line type later on in the when it comes to your technical drawing later on. Okay, the third one is dimensioning. So throughout the years, when I do assessment on technical drawing, because I myself I'm a AutoCAD certified professional, so when I access the work from people, some of the new user, they have problems using the correct dimension. They will do the wrong setting in their drawing, and it means something else, because it's very important, because technical drawing is a communication between the creator or the designer and the person who fabricate it. So if you don't put things clearly in your drawing, and you assume people know what you are thinking, then that is a wrong practice, right? Draftmen, they are paid to fabricate what you draw on the paper, and you have your signature, verified signature on the drawing. So it's not the draft, it's not the production floor mistake if you accidentally draw the wrong line or you put in the wrong decimal place in your drawing. Okay, so just take note, because later on your position after you graduate with a degree, you very high chances you are the one who, you will be the designer, you will be um, the engineer who create the drawing. Okay, so you are the one who will affect the quality of the end results, end product. So just be careful when you give drawing later on. Okay, so for example, there will be some component for the magnitude of that particular dimension, and there will be some limit, there will be some dimension line, extension line, and all this. So there are some setting on this one. Okay, all right. So for example, you see on this table, there are different limit, although they you can say they have the same meaning, but different type of presentation you can find in the drawing. For example, the first one, so it's a vertical dimension change, and the last one also vertical dimension change, but you see that the last one they use arrow, this one they use 45-degree short line to represent the end point of the line. Okay, so different designer they use different, or different company they have different standard. So when you join a company, be sure that you check their handbook, their company handbook, or their internal circular on the standard in their drawing. Okay, right. So each one of these, you can say they carry the same meaning, only that the standard practice is different. Some people like to use, some company they use this one. You'll see this kind of drawing in civil drawing, means a building projects drawing. This one will be more on the mechanical products, when you do production floor mechanical production, then you see this one. Okay, this one will be more, these two may be more on the component or parts, or maybe some electronics component. For example, IC circuit on your phone, very small, but because you have a hole and all this, so they will make use of the hole, from hole to hole, to represent the magnitude. So this is just a recap on the types of dimensioning. And then the presentation on your technical drawing also, you need to be careful later on when you pass up your report by the end of the semester. Make sure you have a clear orientation. So if your line is this one, you always above the line, always above the line, always above the line, the dimension always above the line. So what happens if it's 180 vertical line, you're always on the left hand side. Okay, you're always on the left hand side, and on top of the line. Okay, the numbers are always on the left hand side, or if the angle, you rotate the angle of the line, the dimension will be above the line. Okay, so just take care, just take care. You will see some of your partners, they use dimension below the line. That is not the standard practice. So this is what the industry practice. So just take care on the location, how you position the things. Okay, right. And I have seen some of the student drawing which is quite terrible, where there's a crossing of the line when they do dimensioning. So it is quite hectic when you read at their drawing. You don't know which line refer to which one. So just make your drawing a little bit clearer when you present your idea later on. Okay. Another one is on circular dimension. Circular dimension means you deal with angle. So there are some representative that you option that you can use. Either you use arrow to arrow, then you put a degree there, or you can use a symbol, angle symbol, to represent the angle. Okay, so there are two practices example here. All right, or another one is this one, without angle, but you will see there's a curvature. They will follow the shape of the parts from point to point. Then they give the dimension. And then when you have a curve, there will be a locus. There will be a center point of the curve. Right? You draw a circle, there will be a center point for the circle, right? So this point is important because especially when it comes to metal stamping, or you need to bend the metal sheet. There will be a center point for the bending, for the machine to bend the metal sheet. So if you don't put this one, it's very difficult for the manufacturing production floor to keep up with what you need. So if you don't put this one, they can still make the thing, but when it comes to QC, when you want to pass the object to your customer, especially you're producing a prototypes, if you accidentally but you forget to put this one in your drawing, you know that in your 3D model you can always measure, but when you pass the information to production floor, you accidentally remove this dimension or this entity. Then when it comes to QC, they don't know whether they want to pass or fail this object or this component. So when they pass, they chop pass, but when it comes to customer, they cannot fit properly into the component. Then they have to reject the component. And again, in manufacturing, in the real world working environment, if you're dealing with manufacturing, means you'll go into production, mass production. Means if you one wrong mistake from the a designer or on the technical drawing, the whole lot will be pulled back and become scrap. So it will be because if you imagine one component that actually will have a corner. Nowadays, all the consumer, you can say most of the consumer product, they have a curve corner. So if you don't do properly, you cannot fit in. You cannot fit into the electronic component. So if you cannot fit in, then you cannot use already. You have to scrap and become a recycled material. So, and you have to redo the parts. Okay. So be careful on all this dimensioning. We will come to this one later on. This one will be the header in your 2D drawing later on. So when you pass up your drawing later on, as we progress, because later on you need to submit drawing by drawing and drawing with the improvement. So we will expect that there is a division or there is a revision column in your 2D drawing, or maybe in 3D drawing. There will be changes recorded in your 2D drawing, in your header, in your plan header. So there will be revision. So for example, revision 0. Revision 0 is nothing, but revision 1, what have been changes? When we do about optimization later on, you need to change some of the parameter, right? So if you, let's say you change this curve. The first drawing you submit to me, you're using this one, but after some consideration, after you've done simulation, you found out that this corner have experienced a high stress, and you need to thicker. You need to make this component a bit thicker. From 25, it increased to 30. So there's a new revision of drawing. So when you pass up your drawing in one of the meeting or one of the week later on, I will expect to see you have some record in your plan there. So for example, revision 1, what is the date of changes? What have changed? For example, here I will see thickness, thickness 30, area what? So in your plan you have area, right? So you should put something here. Okay. Second one, in your plan, plan index means your revision, and then your name and the projects. I will expect you put something for your name, the name of the project. So each one of you, we have 2 projects in our class. So just put in your title of your projects. Clients will be the clients here. You put in the module code. Design author. So this one you put in your name and your team member name, the one who draw it. So you have so many parts in your project, so I will expect the name will be different, right? So if I see all the drawing same name, so I just give marks to the one who draw here lah. Okay, let's say you have 2 member, so when it come to assess the report, they will be marked for technical drawing. So I check the technical drawing. If your name keep appearing, then you will keep scoring marks. If your name do not appear in technical drawing, means you do not contribute, then I will give mark accordingly lah. So if 10 drawing, all the 10 name is one of your team member, your name do not appear, means 0 mark for technical drawing lah, on your side. Okay, so this is how we mark lah. So be careful. If you draw, you have to make sure your name is there. Yeah. So author, plate number, this one normally don't have, but you can put lah. If you have anything notes here, you can put content. If you have, then you put. Sometimes in manufacturing, you have a finishing process, right? But for your project, I don't think you have finishing remark there. Current state and draft person. This one is who draft. So normally the design author, and for this module, design author and the draft man will be the same name, for example. All right. So these are the information we expected in your report later on. Okay. But anyway, I will still remind you on what is important later on. Okay, and there are lots of standard. Okay, so we are all engineer. We need to follow standard. Okay, so when you do something, there will be a standard behind it. So for example, the first one, the ISO 128. ISO 128 deal with technical drawing and general principles of presentation. How you present a good technical drawing. So this standard, inside this standard, you mentioned you should have what, how you draw, how you label, how you use dimensioning, how do you use tolerance. If you draw screw, what should you put in, for example, right? So all these will have all this now. So you can read through in my slides later on. Next one. This one will be more related to what you need to do from today onwards. All right. So today onwards, you need to generate a 3D model, put them into drawing. Okay. Use software. You can use SolidWorks, you can use AutoCAD, or you can use Pro-E if you want, as long as it's you can generate 3D modeling and technical drawing later on. So let's say you have a 3D model like this. Then recall what is all the view means. What is the front view? What is the top view? Or what is the right view, left view, bottom, and rear view? Okay, so these are all the general dimension that you should aware of. All right. And put all your object in the general orientation. For example, later I'll use an assembly drawing for explanation. Let's say you have a 3D model like this. So you learn this one in your CAD drawing class. So you have your front view, top view, bottom view, right view, left view, and rear view. You can do setting in the software to give you all this view, right? So always give your view when on how the object operate in the real case. For example, if you fabricate or you use the object in this orientation, then you should, all the drawing you should give according to this orientation. Your y-axis is going up here, your z-axis here, your x-axis here, meaning your drawing, you have a reference point there. For example, your center point is here. So all the dimension will refer to your global reference point. Okay, so just take note on that. Don't one object do this orientation, another object you do another orientation. You should put all object to using the same orientation. Okay. So this is what you need to do for today homework. You need to generate an assembly drawing. There will be another standard that you can refer to, for example, ASME standard. Okay, ASME standard, or you can use ISO standard to generate the drawing. Okay, so this is one of the example that we expect you to generate in this Capstone Design tool. So for today, I will expect you to generate the 3D modeling, the 3D model for your projects. All right. So later on, after this class, until next class, you need to discuss with your partners, and you distribute your tasks evenly, and then each one of you generate a 3D model together, and by next week or by another 2 weeks, right? This week and another week, I give you 2 weeks to generate 3D model. So this week, if you can finish by next week, right? It means you use 1 week. By next lecture, I will expect you to have the 3D model ready already. Okay. So again, you can use any 3D model software, modeling software. You can use AutoCAD, you can use SolidWorks, you can use Pro-E or other 3D model software to generate the one that you design in Capstone Design 1. Okay, previously you present about hand scratching and all this. So within these 2 weeks time, from today, count from today, I will expect you to generate 3D model using software. Okay, then later, next class, I will teach you, I will remind you on how to set up or what are the requirements in your 2D drawing. Means you import your 3D model into a template. Okay, what are the things that you should have and all this in detail. I will brief you in detail. This week, I will expect you to start developing the 3D model. Okay, so just a brief and give you some idea what is expected by the end of your report. We will expect you to give us the correct template, A4 size with region 1, 2, 3, 4, and region A, B, sometimes C. Okay, so this is, I'm not sure, this is using, this is scale 1 to 2. Okay, so because I don't have the dimension here, but anyway, I will expect you to use the correct template, means A4 template, and use the correct sizing, like just now I mentioned, and then there will be some part list over here. This, yeah, this some part list, or we call it boom. Let me see. Yeah, so there will be a part list in your drawing later on. We call it BOM, or bill of material. So this is the bill of material. So today homework, beside you are generating the 3D model, on your hand, when you draw the exploded view, you should ready the bill of material by next meeting, okay, by next lecture. So this one you already have already, I think. You just need to put them on inside the paper. Just ready, this one. Later you just copy the information and put in the template. Okay. Yeah, this is one of the things that you need to ready when you submit by the end of the semester. This is another example. All right. So this is what you need to do within these 2 weeks. Then after you generate a 3D model, I will give you some theory on what is expected in a 2D drawing. So this one later, okay? Your today homework is to generate 3D model like this. Okay, generate exploded drawing. Again, the time frame I give you is 2 weeks. So if you can complete by next lecture, which is good. If cannot, maximum you can drag is until another 2 weeks times. Okay, so plan your time carefully. Then this one, I'll brief you more detail when it comes to time. Okay, maybe next week I'll start briefing you what are expected in your 2D drawing. Okay, we can only come into this area or this technical drawing in 2D, or we call it detailed drawing. Okay, this is assembly drawing. So this is your homework. You need to generate assembly drawing within these 2 weeks. All right, maximum I can give you until another 2 weeks from now. Okay, if you're not able to generate assembly drawing by next 2 weeks, then your workload will going to be add on and on, because later on after 2 weeks we are going to start doing optimization. So optimization means you need to always update your 3D model and your 2D drawing. Means you'll start to have the revision of changes already.
Sir, excuse me, sir.
Yes, go ahead.
When you mean 2 weeks, you mean next week Thursday's class, right?
You don't need means next week what I expected from you. You need to present to me what is the progress that you have done. Okay, so by next week I will expect you to generate, because I think your project have more than 20 parts. So I will expect you to at least you solve 50% of the 3D model, at least 50%. Okay. So if your project have less parts, then you can complete by next week. If not, then you need to plan your time and try to complete all the 3D model within the 2 weeks time. So it means every week we will give you chances to present your progress. So you need to tell me, oh, this is the parts that I generate. Okay. Then I'll give comment what need to take care of, and then you make improvement on the original drawing. Okay. Right, so next week, what I expect is your team already have some or 50% of the 3D model. The purpose of your homework or objective is to generate assembly drawing by next lecture, or maximum you can drag is 2 weeks from now. Maximum 2 weeks from now to generate the assembly drawing. Okay. So next week I will give you more detail on the template already. So if you don't do anything within these 2 weeks, then your workload will be added again and again, right? So it will be a very industrial setting. So if you don't do work these 2 weeks, then you will be very hectic for you, because incoming you'll be near to week 7, week 8. Then your test one for other module will be coming, and you will freak out. Okay, you'll freak out. I don't want you to fall into that situation. So plan your time, because after this, beside this drawing, you need to convert 3D model into detailed drawing. So there are lots of work to do. So if you can, when you have time, start doing something on Capstone Design too. So this is also the homework that will be coming. So only for this week or next 2 weeks, you need to start on a 3D model. Then another thing will come in is we will talk about detail drawing. Okay, this is the thing lah. Okay, the detail, the template we will discuss in next lecture. I'll give you some example. For example, the toe stop assembly. For example, this one. You already have the hand sketching. So what we expect you by next lecture or next lecture, we expect you to come up with the 3D model and then do the numbering for the object. For example, this one, sorry, too small. This one is number 3. This one number 3, and so on. So you should, after you come up with the part, I think you already showed me the hand scratching already, which is good. You only need to convert the parts into 3D model and then generate the boom. Okay, assembly, and then you put all the parts together in one domain or one window. Then you import the parts into one window, and then you do labeling with balloon. If you can generate some parts number, just a artificial part number. For example, this part, number 3, you give a number for this part. For example, MIU 001 for 003 for this one. If you go to industry later on, people don't talk about the name of the component. They will say, okay, what part number you use. Means if you're referring to this part, you just say MIU 003, referring to this part. So in the industry, when people say, oh, this part got problem, you need to shorten the length of this part. They will not use the name of this part because there are thousands of parts in the industry or in that particular projects. So they will mention referring to drawing number or the part number MIU 003. You need to shorten, use a bigger size diameter or longer length to screw in this hole. So they will mention the part number rather than the name of the part number. So this is what is going to happen in the industry. I'll tell you a joke. When I work as a project engineer as my first job, when I joined the company, I didn't know what is this mean. Really, it became a joke of the day. I think the first week when I joined the company, I don't know the parts number. What I mean by part number? I was confused. What is the part number means? But after a while, then I know what's happening. Then, yeah, I get the job done. Okay. So this is what I expected in this 2 weeks time. If can, you complete within 1 week. If not, then maximum 2 weeks. You come up with this kind of drawing. Means you show how you assemble the things with the line. You see this one, the line. How you go in the hole. How this join this hole, and then how you screw the thing. For example, sorry, there's a maximum size of my green screen. So you can see the part number 4 and number 6 over there is assembly through the hole there. So you see there's a line like this one on the screw there, and below also you see the same assembly line. So something like this expect from you for the next 2 weeks. All right. And get ready the boom list, the bill of material. All right. So for example, part number, since you already label the parts in your project, so parts number, let's say parts number 3, then you give it a name, and then the material, and then quantity. So this is the data that you should get ready. I think this one you have already, only you need to extract the information and put them in a document. So part number, you assign a part number to the diagram. So 1, 2, 3, 4. description, what is the name, what is the material that you use. Okay. So here, if you use the same, if you already can decide, then you put. If there is if the component have a different material, then you put in refer drawing number what, or refer sheet number what. Okay. So for example, this one, number six, it have a lot of process. So the process will in detail is covered in drawing number 3. Okay, and you need 2 of the washer. Okay, so again, your homework, generate 3D model. If can, generate the assembly drawing by this week. If not, drag until 2 weeks from now. You should already get ready the assembly drawing with the boom list. Okay, with the boom list. Okay, so next week, show me your progress. I'll expect at least 50% from your projects. Huh? All right. If can, you draw complete, then you can follow along. Next one, for example, the next one, before you can generate this one, you need to refine the dimension for your component. Okay, so you need to go back to your hand scratching, give a full dimension of your component, individual component. Okay, so you should have the full dimension of your component. Okay, so this one, you can do hand sketching by next week. Because if your projects have a lot of component, you can show me the hand sketching with the dimension. Then another 2 weeks from now, I'll expect you to turn all this into a 3D model. You show all this in the your software drawing. Okay, you input all this into your 3D model. Okay, your homework today, generate 3D model. Go back to your Capstone Design 1, extract the boom list, the bill of material, the part list. Or if you haven't generate this week, then look at the parts that you're in charge of. Go into the detail, give the detail of dimension. Again, you can hand sketch, or by the end of the semester, when you submit your report, I expect to see this one, the 3D model with dimension in a software. Okay, I will not accept hand scratching by the end of the semester. If you pass up hand scratching, I will make a remark on that. Do not meet industrial standard. You have a score mark, a very low score mark for your drawings, right? Because you are doing a degree level. So we need to be careful on the standard that we see, because later your drawing, your report will be assessed by external examiner. So they will see whether you really do it according to industrial standard or not. Okay, so just take note on that. Okay, I'll give you some rooms to pick up the speed. So for this week, again, you can generate using hand scratching, but by the end of the semester, when you pass up report, or I keep reminding you to change your 3D model into the software and put in the dimension as what you see on the slides. Okay, so this is what we expect from you within these 2 weeks time. So if you can complete this one, then we are good, because all these are industrial standard, right? And we don't want you to panic when you join the workforce on the first day of your office life. An example, let's say you're designing a text fixture assembly. So again, you have all these parts, and although this one is used hand stretching, this one um, is on the design stage where we expect from the Capstone Design 1. So most of you haven't do this one. All of you do hand sketching. So I will expect you for these 2 weeks, you can convert your hand sketching into using software to convert them into 3D modeling and then input them into a drawing, assembly drawing, and give them a bubble, label the parts number 1, 2, 3, 4 until 6, or until the last number of the parts, and then ready the boom list. Okay, ready the boom list, bill of material. So this is how you do assembly drawing. So you import all the individual parts into the software, and you can input the motion or the assembly line. For example, this hole, the center of this hole will go mid to the center of this location. So you draw a line from the center to the center of this hole. Then you use assembly line to tell the reader of your drawing that this hole actually go to here. Same with this one. Okay, this hole will go to here. And then how you assembly the screw or how you mount the parts together, you start with this part go through this center hole and go to this center hole and so on. Then you have a washer and screw there. Okay, something like this. This is an example of assembly drawing that I expect from you 2 weeks from now. Okay, boom list again, another example of boom list. Parts number, name, description, or just now more complete one is a material. You can see the material and number of quantity, right? QTY means quantity. How many parts of that? Okay. Okay. Why you need this part list? Because later you need to do when you do costing. When you do costing later on, the number inside here and the material of that part will play a important information to calculate the total cost of your object. Okay, so all this will link up later on. Okay. So for example, you have the 3D model and then you generate individual parts within this week or next week. So these are the things that we expect from you. So you generate individual object with the dimension. Again, for this week, if you so many parts you need to draw, I can allow you to use hand sketching at first, but after 2 weeks times, I will expect you to input all the dimension in the software already. Okay. Yeah. So this is your homework. So these are another parts. These are another parts from here. Okay, more detailed dimension. What is the dimension outline? Where is the hole? What is the angle between the hole? Okay, all this. Then the plate, base plate, like this. Okay. Okay, base plate like this. So what are all the dimension? And when you give dimension again, have a very clean drawing. What I mean by clean drawing? I've seen students, for example, this 4 mm diameter, they will try to drag this 4 mm and intersect with this line. I don't know why I keep seeing students intersecting line in the drawing. Like for example, they will do something like they'll pull this line somewhere in the middle, and then the line will go past the line. Means there's a crossing of the line, and it's quite confusing. So don't do that kind of activity in your capstone 2. Since you're in my class, I don't expect student after my class they still doing the mistakes, right? Yeah, yeah. So yeah, I'm quite strict when it comes to standard. So if you don't do it right, I will just tell you, and if you're still not correcting it, then yeah, you'll see something happen to your marks. Okay, yeah. Because this is a time I do correction, because when you go to work later on, you are projecting what you learn in your degree, right? And when you tell that Dr. Ang teach you before, then they expect a good student from you. Okay. Okay, these are the example of 3D model that we expect from you in Capstone 2. So something like this, right? When you do assembly. But again, for this week, we don't expect you to, if you can, you do. If not, you use 2 weeks time to assembly the parts. Okay, but this week, I will expect you to give me assembly drawing like this. Okay? I will expect, give me assembly drawing like this, and prepare the boom list and individual parts dimension. That is the homework for these 2 weeks. Okay. So I'll give you a few examples. This will be the end results that I expect from you by the end of the semester. There will be 1 pages of assembly drawing, something like this. This one generated by ProE. So we'll see you are using the correct template. You have the boom list or material list or part list. Then you are giving all the information inside the template and the revision, and then the balloon of the parts, and you show your consumer or your reader how you assemble the parts. This will be the goal by end of the semester. Okay, if you able to give this one by the end of semester, you will score quite high in Capstone Design 2. Okay, so this is only one part for Capstone Design 2 where you generate report, and in your report you need to show a good standard of technical drawing. All right. Another part for Capstone 2 is your products. You need to fabricate the products. Okay. So yeah, have some idea what's going to happen for the next 2 weeks or for the coming 10 weeks. What's going to happen. Okay. So again, just to recap the homework for today. Convert your model into 3D model. Next lecture, I will give you the 2D drawing requirement or the template for you to input your 3D model into the template. Okay. Okay, I end the recording.